Hello everyone, today I'm going to show you how to calculate the derivatives in AX functions. As we know, in the exponential derivative functions, there are two basic formulas. One is xn derivative equals n times x power of n minus 1. The another one is ex derivative equals ex. However, how to calculate the derivative in AX? For example, if we want to calculate the derivative in the function 5 power of x, at first we should do the logarithm in both sides of this function. So logarithm y equals logarithm 5 power of x equals x times logarithm 5. Then we do the derivative in both sides. However, you should keep in mind that the y is a function of x, so the derivative in logarithm y should be y derivative divided by y equals 1 times logarithm 5. So the derivative y equals y times logarithm 5, which equals 5 power of x times logarithm 5. For the second derivative, which is the derivative in the first derivative functions, so the first derivative function is 5 power of x times logarithm 5. So it is a derivative equals logarithm 5 times derivative in 5 power of x, which equals logarithm 5 power of 2 times 5 power of x. Similarly, we can make a reasonable assumption that nth order derivative equals logarithm 5 power of n times 5x. So for the general function y equals ax, we can assume its nth order derivative should be ax times logarithm a power of n. Here a should be more than 0. So we have to prove this assumption is right. Then we have to use the induction method. Induction method includes 3 steps. At first, we have to prove when n equals 1 or the first derivative, this assumption is right. So in order to calculate the first derivative in this function, similarly, we should do the natural logarithm in both sides. So logarithm y equals logarithm ax equals x times logarithm a. Then we do the derivative in both sides. Just keep in mind here, the y is a function of x, so the derivative in logarithm y should be y derivative divided by y, and x times logarithm a derivative equals 1 times logarithm a. So the first order derivative equals y logarithm a equals ax times logarithm a. So this expression is exactly the same as here when n equals 1. So this assumption is true for n equals 1. For the second step, we just assume when n equals k, this assumption is right. So for the kth order derivative, we can have a power of x times logarithm a power of k. Now for the third step, we have to prove that when n equals k plus 1, this statement is right. So for the k plus 1 derivative, it is a derivative on the kth order derivative functions. And the first order derivative function is ax times logarithm a power of k. So it's a derivative on the kth order derivative functions, which equals logarithm a power of k times derivative on the function a power of x. And ax derivative is equals ax times logarithm a, as we proved here. So we can get logarithm a power of k times ax times logarithm a equals logarithm a power of k plus 1 times function ax. For the n equals k plus 1, this expression is exactly the same as here when n equals k plus 1. That means this assumption is right for the n equals k plus 1. So based on these three steps, we prove that for the function ax, its nth order derivative should be ax times logarithm a power of n. That's all for today. Thank you for watching.